what I can choose on the function generator is several kinds of oscillations. And the easiest one is one that varies sinusoidally.
Is it supposed to go fast and slow down?
What's that?
Is it supposed to go fast and then slow down?
Is that what it's doing?
Yeah, it just
Yeah,
takes
so
a-
there's
it
something
takes a little-
wrong.
It takes a little bit of time, it was just going fast and slow.
But it's not, and it's also not reading this, because it should show the oscillation.
Occasionally it does show like a piece of an oscillation, like it'll flash it, but
You mean
it'll flash like half of an arc that's kind of disconnected.
oh, now it's showing actually. Okay, let me figure this out before, either tomorrow or Friday. So, as long as I have it here, I'll just say this. So, this is called the function generator, and what generates an alternating output, or it's called a function generator because it gives you different kinds of oscillations. And those of you that are up close can see that there's a sinusoidal oscillation. There's a linear oscillation, which is called the triangular wave, triangular function. And then there's a square function, where it goes high, stays high, goes low, stays low, goes high, stays high. And so when it's displayed, it forms a square wave. And then there are combinations of these that this doesn't have, but the one we're going to use, not this week, but next week, it can have this plus the square, so it can do this. So it goes linearly up, and then it drops very fast to 0. And then it does this. And this is called ramp up, or sometimes called the sawtooth. Or it could do the other. It could ramp up and then ramp down. This is kind of a reverse sawtooth. And so the function generator, or the oscillator, gives you all these options for output. But in order to see them, you need the scope, the oscilloscope that can read an oscillating voltage. And this you can see is 5 generations ago technology. And what we have now, like most of this is an analog scope, most of them is a digital. But we have this that we used, we haven't used it this semester, but we will use it tomorrow, that can do a variety of things. But this, inside of this, is a function generator and an oscilloscope. So what this does is this digitally can read the voltage very, very fast, digitally, and display it. And the way you display the voltage here, there's no screen, it has to connect to the computer. So this is what we're going to use tomorrow, not to do these kind of circuits, we'll do that next week, but to take a magnet, a series of magnets and a series of coils, and drop them through the coil. And the magnet goes through the coil, there's a rise and a fall of voltage that happens pretty quickly. And so the fast-acting voltmeter will be able to collect the data every thousandth of a second and display what it sees. And I showed you that the other day. If we watch, and that's what the oscilloscope is doing, it's showing us voltage over time. And so as the voltage varies over time, we see what it's doing. And you have to adjust the rate at which it shows you according to how fast this is oscillating. So tomorrow what will happen is, when you drop the magnet, as it's approaching, there'll be very little happening, but then when the magnet starts to enter the coil, the voltage will rise. And then once it gets in the coil, it will stop rising. And when it's right in the center, as the magnet is in the center, the flux through the coil for a short period of time isn't changing. And then it'll start to fall out. And so you'll get an opposite voltage. And so you'll see a display like that, watching voltage over time. And this doesn't repeat, right? Because you're just dropping the magnet through. And this is what we'll do tomorrow using this setup, but this setup has to be connected to a computer to display it. Okay. So let me